So the first property that we're going to learn about is the angle subtended by the chord at point. So suppose we have a triangle that is PQR and we have the angle R. So we can say that this angle R is basically an angle that is subtended by PQ at the point R. Now let us suppose that these 3 points, that is PQR, they lie on a circle, and as we see that PQ is the chord of the circle and the point R is somewhere on the circle. So we can say that the chord PQ is subtending the angle at the point R. Imagine if the point is not at the circle but inside the circle, that is, it be at the center of the circle, then the angle will be subtended like here, that is, the angle is subtended at the center of the circle. So we can say that the angle O is the angle that is subtended by the chord PQ of the circle. So this is how the angle is subtended by the chord at different points. Now let us learn about the theorems. So the theorem 1 states that equal chords of a circle subtend equal angles at the center. We see that we have the circle and we have two chords, that is AB and CD are the two chords, and these chords are given to be of equal length. So AB is equal to CD. And according to the question, the angles subtended by these chords are angle AOB and COD, they are to be equal. This is the angle AOB and this is the angle COD. So according to the theorem, these two angles are supposed to be equal to one another if the chords are equal. So accordingly we can write that angle AOB is equal to angle COD. This is what the theorem states and this is what we have to prove. And it is given that AB is equal to CD, that is, the chords are equal. So we have two triangles, that is AOB and COD. So in triangles AOB and the triangle COD, we have AO is equal to CO, as these are the radius of the circle since the radius remains constant, and BO is equal to DO, again the same reason, and AB is equal to CD. This is what is given to us. So looking at these three situations, we can say that the triangle AOB is congruent to triangle COD by SSS rule. So thus what we can conclude is that angle AOB is equal to angle COD, since the corresponding sides and the corresponding angles are equal. So we can say that the equal chords of a circle subtend equal angles at the center. Now we have another theorem, that is the theorem 2, which is the reverse of the theorem first, and states that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. In this theorem, it is saying that the angles that are subtended are given to be equal. So we have two triangles, that is triangle AOB and triangle COD, and we have been given that the angle subtended by the chords, that is angle AOB, is equal to angle COD. So this is already given to us. We see that AO is equal to CO and BO is equal to DO, as these are the radius of the circles. So we can say that the triangle AOB is congruent to triangle COD by SAS rule. So the chords, that is the chords AB and CD, these are equal. So it states that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So this is what we have proved. Now let us do an example in order to understand this concept. So we have the example as, prove that equal chords of the congruent circles subtend equal angles at their centers. So we have been given that the chords of the circle are equal and these circles are congruent. So equal chords and congruent circles, and we need to prove that they subtend equal angles at their centers. So we have two circles, these are congruent. So let me name these angles. Let this be angle 1, this be angle 2. This is the circle C1 and C2. This be the point A, and BC is the chord, and this is the center is the P, and the chord is QR. So we have these two circles and we have the angles. So we need to prove that the angle 1 is equal to angle 2. That is, the subtended angles are equal. So first let us learn what is congruency. So if these circles are said to be congruent, then they will have to overlap each other completely. We have been given that these two circles are congruent. So we can say that the radius of the C1 has to be equal to the radius of C2 circle. That is, they are completely overlapping each other. So definitely the radius has to be equal. Let us take these two triangles in order to prove this. That is the triangle ABC and the triangle PQR. In these two triangles, we can say that BC is equal to QR. This is already given to us. That is, we have been given that the chords of these circles are equal. So BC is equal to QR. Then AB is equal to PQ and AC is equal to PR. Since the circles are given to be congruent and we just showed that the radius of C1 has to be equal to the radius of C2. So by these three facts we can write that these triangles, that is the triangle ABC, is congruent to triangle PQR. By triple S similarity rule, what we can conclude is that the angle, that is the corresponding angles and corresponding sides, are equal if the triangles are congruent. So therefore angle 1 is equal to angle 2. This is what we had to prove.